How can I solve systems using substitution? So here we're going to take these systems we have, y equals 5x plus 17 and y equals x minus 3. And these are already set up in a nice easy way, slope-intercept form, to use substitution because y is set equal to something. So I take this first equation, and instead of putting y, I replace it with a value that's equivalent to y, which is x minus 3. So instead of y, I put x minus 3 equals 5x plus 17, right up here. And then I simply just solve for x. So I take 17 away from both sides. X minus 20 equals 5x. These cancel out. Minus 3 minus 17 is minus 20. I take x away from both sides. I end up with negative 20 equals 4x. Divide both sides by 4. X equals negative 5. So I figured out one coordinate now for the solution. I then have to go back, and I can use either of these equations and I substitute this value in. This equation looks easier to work with, so I'm going to use that. And I substitute in x equals negative 5, so y equals negative 5 minus 3. At y equals negative 8. My coordinates for the solution are negative 5, negative 8. Here's another example. It gets a little bit harder here because this one is not in slope-intercept form. And since it's not in slope-intercept form, I use the second equation, which is already with y equal to x minus 1, and I simply take this value and plug it in for y in this first equation. So I do negative 2x plus 3 times x minus 1 equals 4. Negative 2x plus 3x minus 3. I add 3 to both sides to eliminate the 3 here. I end up with, and then I combine these terms, negative 2x plus 3x is equal to x. So x equals 4 plus 3 is 7. X equals 7. I'm halfway done. I take this value and I'm going to substitute it back into the second equation. It doesn't matter which one you do. I chose the second one because it looks a lot easier. X equals 7, so I do y equals 7 minus 1. And 7 minus 1 is 6. My coordinates are 7, 6. Finally, here's a third way you'll see this, where your two equations are set up like this. In the system of equations, I have two of them that are not in slope-intercept form. So I pick one of them. In this case, I picked this second one. And I solve for one of the variables. I'm going to solve for y. So I add x to both sides. I end up with y equals 3 plus x. So then I take this and I substitute it back into the first equation. Minus 3x plus 3 times 3 plus x equals 4. When I distribute this 3, I end up with plus 3x here, and I have minus 3x here. So when I combine these like terms, I have 0x. What it then leaves me with is this this equation that says 9 equals 4. That is false. Since that's false, I actually have no solutions and I'm done. These two lines end up being parallel. These two that I originally started with are parallel lines. They would not cross. There's no solution in that case. If you had a case where this was the same and it was 9 equals 9, that's a case where you have infinite solutions and they'd be the exact same line. Again, this is how can I solve systems using substitution.